Good morning, everyone. Can you hear me?
Yes, we can hear you.
Okay, thank you. Okay, so today we will be talking about lab number 5, or in other words, that's going to be your final project. So there's going to be some creativity while we are doing that, but I'm going to go today through all the details. My request is you pay a very good attention because many rules here for the design can significantly change your design and make it much easier if you pay attention to it. And if you don't, you're just going to be, running in circles and get things very complicated. Okay. So that's going to be counted toward your final project grade. It's not going to be a regular lab. You're still going to be working in groups like the other regular labs, which means that you will also be submitting a final project report as a group, but you are responsible to create your own circuit. I'm going to go today through the details of the project, and for chapter 5, I'm going to upload a quiz that's going to be offline, which means you can do it anytime as long as it is before the due date, and I think I'm going to have the due date to be Sunday night, just to give you the weekend as a buffer for you. The other thing, because this is a final project, it's not going to be due right away. It's going to be due the next Wednesday. So you have all the way until next week to submit your final project report, and you get your circuit working and everything is done. So you have time, but that doesn't mean that you just put it on the side. You need to work on it, especially the pre-lab. The pre-lab is very crucial. I think that is 90% of the work. If you get it right and you understand the rules and you know where the trick is in this design, you're going to make it much simpler and easier when you just put the wires together. Okay. Also, the third announcement for your final exam. Your final exam is going to be in the exam week. Let me check here the calendar again. So it's going to be May 13. It's going to be a Thursday. It's going to be from 8 a.m. to 10. So what I will do is I will make the exam available starting from 7:30 all the way to 10:30. Okay, which means that whenever you log in, you have 2 hours to finish it. And it's also going to be using Respondent's Lockdown browser. The same way, it's also going to be multiple choice exam. Okay, so now let's work on the final project here, the light controller, the traffic light controller. I'm going to read the description first and show you how we're going to extract information from that description. So what we want to do here is to design a digital logic circuit which will implement an intersection traffic controller for a highway intersection. So you have north, south, and you have east, west. The vehicle direction sensors are placed along lanes A, B in the north-south direction. Okay, as we see here, A and B. And in the east-west direction is going to be the D and C. So you're having sensors here. Those sensors are going to be on and off, or it's going to be 1 or 0. And based on how these sensors are going to behave, I will decide at the end to have a red light or a green one. This should be green. Okay, so I will have a red light or a green light on the north-south traffic light, or on the east-west traffic light. Because of course, in this intersection, we always know that if you have a traffic light here, if it's red here, most probably it is red here. We're not doing a complicated one where you have turn right and turn left and all of that. It's just a very simple traffic light. So both of these will be red at the same time. And if these two are red, these two are going to be green. And if the others are green, this is going to be red, and so on. Okay. So that is number 1. These sensors will give a high signal when a vehicle is present. So when I say that A is equal to 1, it means that I have a car in lane number A. Okay, I have a car here in lane number A. It means that A is equal to 1. If, for example, C is equal to 1, it means that I have a car or 2 or whatever number of car. I really don't care about the number of cars, but at least there's one car that exists there. If it's vacant, there's no cars in the lane, then that's when it's going to equal to 0. So A equal to 1, whether it is the A, B, C, or D, these are going to be your inputs. Okay, your inputs, if you have a car, so if it's occupied by a car, your input signal is going to be 1. If it's vacant, your input signal is going to be 0. Okay, so that is the input. I didn't talk yet about the output. That's the input. Okay, so it will give you a high when the vehicle is present, and it will give you a low when the vehicle, when no vehicle is present. Okay, design a simplified logic circuit to control that traffic light. And there should be 2 outputs, of course. We have the north-south and the east-west, okay? Now, pay attention to this part. So now we've talked about the inputs. Now let's talk about the outputs. And the outputs, I have east-west, that's one output, and I have another output that's called north-south. And those are gonna go low when the corresponding light is green. So it's gonna equal to 0 when it's green, and it's gonna equal to 1 when it's red. Okay, so that's a little bit different from what we are used to have. The same thing here is gonna be 0 when it's green, and it's gonna be 1 when it's red. So this will need some work in your LED display. You might need to be changing colors or something like that, okay? So that's one other piece of information. Now the traffic control logic for this intersection must follow some rules, okay? It's not like, what if I have a car at the intersection C and D, and I have cars at A and B? The traffic light, which one is going to be red, which one is going to be green? So I have to put some rules there so it can arrange when the east-west is going to be green and when the north-south is going to be green. And that's what we're going to be working on in the next slide. So these are the rules here. Let's pay attention to the rules and let's see how we can translate that into a truth table, okay? So now for the first one is saying that the east-west traffic light must be green. So the east-west traffic light must be green. In other words, it has to equal to 0 whenever both lanes C and D are occupied. So which means that, of course, every time we have A, B, C, and D, right? These are the 4 inputs. Now it's only talking about the C and D. So can someone unmute yourself and tell me, what does the word both lanes C and D are occupied? What does that mean? What are the values of C and D? And what are the values for A and B?
A and B would
C
be
and D are
0.
1, and then A and B are 0.
Who's talking right now?
It was me.
Marcus. Okay, go ahead.
Okay, so if C and D are occupied, wouldn't they be both 1, and then A and B are not, then they'll be 0. So
well, I didn't say, hold on. This is, it's good that you raised that point. I didn't say anything about A and B.
okay,
I didn't give you anything
asking
about it, right? So C and D are occupied, okay, but what about A and D, A and B? I didn't say anything about it, so what do you think?
Or they don't care?
Wonderful. They're going to be, I don't care. If there's cars at A and B, if there's a car at B only, if there's a car at A only, if both of them have cars, I really don't care. As long as C and D are occupied, my light is going to be green in the east-west side, which means that, so the don't care means that if both of them are 0, also my east-west is going to equal, is going to be green. If it's 0, 1, if it's 1, 0, if it's 1, 1, as long as these 2 are equal to 1, okay, I'm going to have my light green at the east-west side. So I want you to pay attention. I'm stopping at the first one because the wording is very important, is very precise. I said both lanes, C and D are occupied. So Marcus said it right. C and D has to be 1, 1. But I didn't say anything about the A and B, which means that, well, I don't really care. if both of them are vacant, if one of them has a vehicle and the other is vacant, or if even both of them are have cars. I really don't care. As long as C and D are occupied, the east-west green light is going to turn on. Is that clear?
Yes, ma'am.
Okay. So that is number one. Now, that is rule number one. Because I want you to, I want you to like brainstorm and think with me. I don't want to just do it. You have to think with me. So let's think about the second one. I'm going to give you like a minute to think about it, and then we will start to work on it. See, this project, if you are able to understand it, if you're able to try to come with conclusions on your own, like what Brian did, what Marcus, these kind of things, that's what you're really going to learn from the digital class. So please put all your effort, try to understand this, because that's going to help you with the critical thinking, design thinking as an engineer. Okay, so let's move on to the second one. I'm going to give you a few minutes. The east-west light will be green whenever either lane C or D is occupied, but lane A and B are not both occupied. I'm going to give you a minute. Think about it. What should be the east-west, and what is the A, B, C, and D? What are the possible options that we might find there? Let me just write it.
Will that mean that either one will be a 1 and the other will be a 0 on both sides?
Mm-hmm. So I want you to think about all the possibilities that will exist in this part. So here we got 4 of them. These are 4 possibilities.
Would that mean for 2 that there would only be 2 possibilities?
Well, that's what you need to figure out. So I was about to say, try to figure out how many possibilities should you come up with from that second rule. So the first rule you see here, you have 4 rows here. So this rule was able to get me 4 entries in my truth table. Now for choice number 2, with the rule that I put here, first of all, how many possibilities do you think? Put it in the chat box. Put it in the chat box. I want to see how you guys are thinking. Let's see, how many possibilities were you able to come up with? Okay, 4, 3, 2, 4, 3, 2. Okay, most of you are 4, 2, and 3. Okay, it's still not. That's not what I'm looking for. Let's see if someone else will come up with the correct answer. I need everybody to participate. Tell me, how many entries did you get so far? You know, even if it's not all of them, but how many were you able to get? regardless of how truly many they are. Okay, 15, that's too much. That's the whole truth table. I need more.
Well, you'll get 4, but it doesn't mean they'll all be unique.
Yeah, I understand. When I say possibilities, they shouldn't be unique. Otherwise, it's not a different possibilities. But that's still not the right answer. 3. Okay, I have 1 got it right. Okay, so so far, let's stop here. So far, the one that got it right was Nicholas. And Nicholas, if you can unmute yourself now and tell me how did you think about it? What are the possibilities?
All I really thought about was like 4 possibilities in one and 2 in the other one, and just added that together to get 6.
So say it again. So what is your C and D? What is your A and B? What did you have in your truth table that you showed?
For 1 or 2, or for both of them?
For number 2, this option.
Oh, well, I would have the 4 from the first.
Okay. No, that's not what I mean. I mean, this is going to
Oh.
be new possibilities. These are going to be new possibilities. We're not going to repeat. We're not going to repeat any possibilities. Okay, Marcus, can you tell me what did you get since you write down 8?
I got 6.
Rosa, you got 6 without the first 4, right?
I believe so.
Okay, so can you tell me what are your entries?
0, 0, 0, 1.
That's the first row.
Yes.
Okay.
And then I got 0, 0, 1, 0.
0, 0, 1, 0. Okay.
And then I got 0, 1, 0, 1.
Okay.
And then I got 0, 1, 1, 0.
Okay.
And then I got 1, 0, 0, 1.
Wonderful. Okay, I think you have one more, or
I got 4.
1, 0, 1, 0. Okay.
Yeah,
Yeah,
1, 0, 1, 0.
I think yes. Okay, so you have the right thought. Now, can you explain? Let me just put this down because I want to write it different from what you did. But you did it right, correct? You got all the possibilities. Can you tell me how did you think about it?
Well, the first one I did was they both will have either they'll each have like A will be 1, B will be 0, and then C will be 0, and D will be 1. And then it says that, so they will all be that way. So there's 4 of those. And then it says that A or B are not both occupied. So that means 1 could be occupied on A or B.
Okay, good. So you're going to eliminate the choice that A and B are both 1s.
Right.
Yeah. Okay. And what about the C or D is occupied?
The C or D are occupied.
Yeah. How did you translate that, or how did you think about that one?
Oh, the C and D, it says that either one is occupied.
So what does that mean?
So either C is 0 and D is 1, or C is 1 and D is 0.
Wonderful. Okay. Thank you so much. So exactly like Rosa, I'm going to just re-explain it back again. She started with the A, B, and then the C, D. I will do it with the C, D, and A, B. I will show you both ways how to think about it. So as she said, either lane C or D is occupied, which means that either C is 0, D is 1, or D is 1 and C is 0. So one of them has to be occupied. They both cannot be vacant, and they both can't be occupied. Okay. That what it means, either lane C or D is occupied. Now, lanes A and B are not both occupied. I know that. Let's, I just want to put this here. So A and B are always working together, and C and D are always working together. And because this is 2, these are the all possibilities for any 2 entries, right? The same thing here, 0, 1, 1. So now when I said that either lane C or D is occupied, so it's going to be this choice and this choice. It cannot be this, because this means both vacant and this means both are occupied. So it's not these 2. So I'm going to take only these 2 choices for the C and D. Now for the A and B, it says that A and B are not both occupied, which means that I cannot have the option of 1 and 1. But it didn't say anything about the other 3. So it means that, well, they can both be vacant. They can both, I can have one of them has a car, the other doesn't. Okay, so maybe B has a car, C doesn't, A doesn't, or A has a car and B doesn't. So these 3 possibilities. Now I should take the first one with all 3 and take the second one here with all 3. Then I'm going to end up with 6. So if I take 0, 1, okay, with the 3 possibilities, 0, 1, with the 3 possibilities that I have for A and B, that it's 0, 0, 0, 1, 1, 0. Or for the second possibility here of the CD, that is 1, 0, I'm going to take it with all those 3 possibilities again, that both of them are 0, 0, or 0, 1, or 1, 0. Okay, and now I came up with 6 other entries in my truth table for the traffic light. And of course, this is saying that your east-west is green, so this is going to be 0, means that it is green. Okay, so these are other 6 entries. Now, because I have 4 inputs, how many entries do I have in my truth table? I should expect how many entries in my truth table? Someone can speak it up.
16.
16,
No.
2 to the power of 4. So I'm expecting to have 16 entries. So far, we were able to get 4 and 6. We got 10 of them. Okay, I still need to do 6 more to find them. And that's what we're going to be using the other rules to find them. Okay, so is that clear with these 2 rules? How did we create them? Any questions? Do you want me to repeat? You always think about this part here. So you put these options here and you see which one can be translated. The wording is expressing which of these possibilities together, and you mix and match. Okay, let's continue. So this was number 1, this was number 2. Now let's move on to number 3. And don't forget the A and B and C and D. This can be 0, 1, 0, 1, 0, 0, 1, 1. These are the possibilities, different combinations. Okay, so I'm just putting it here so you can see it. Now let's see number 3. Number 3 says the north-south. Okay, now we're going to be talking about the north-south. The north-south is green. North-south is going to be green, so it's going to equal to 0. Okay, now I have my A, B, C, and D. Let's see what this one is going to come up with. Whenever both lanes A and B are occupied, but C and D are not both occupied. I'm going to give you a few minutes, and then my next question would be, how many entries did you find out in this particular problem? So take a minute and think about what are the different, look at this here and find what are the different possibility combinations that you can get between A, B, and C, D. Okay, some people are starting to put, once you get them ready, you can write down in the chat box the number of possibilities. So Anahi, rethink it again. Josh, Brian, and Tony, you got the numbers right, but we need to see. Yes, Danny, correct. Jacob, correct. Diego, rethink it. Sarah, correct. Eduardo, rethink it. I think you have something extra there. Nicholas, yes, correct. Marcus, you need to rethink that. Mark, what is that? Oh, you're just putting the possibilities themselves. Yeah, Nicholas. Okay, good. Jesus, no, it's not that number. You have something extra there. I want everybody to participate. This is testing your ability to think of a design, of a real design. No, Rosa, you need to rethink that. It's more than that. Anahi, okay, I think you got it right. Okay, Marcus, no, you have something missing. Rosa, that's also not right. Okay, so Nicholas, I want you to unmute and tell me what are your how did you think about your three possibilities?
The way I thought about it, since both lanes A and B are occupied, A and B will be 1-1
Good.
for all of them.
Okay, so that's the only option from A and B. Good.
And then for C, D, it's green when they are not both occupied. So it'll be all the options besides 1-1.
Good. So it'll be these options here. So when I do mix and match, I'm just going to take the 1-1, okay, with the three other possibilities that I have here, which is 0, 0, 0, 1, and 1, 0. Okay, so now I have three more options here. Thank you. Is that clear? Anybody wants me to re-explain it? So what Nicholas was saying here, both lanes A and B are occupied. So this is very straightforward. Both are occupied means both of them are 1-1. That's it. Okay. The other option, C and D are not both occupied, which means that they can both be vacant or one of them is occupied and the other is not. So it can be all the different possibilities except the possibility that both of them are occupied. Okay, so it means that from the CD, I have three different possibilities. From the AB, it's only one. So that one option is going to go with the other three options. You get three different options here. Okay, thank you. Now let's move on to number 4. That says that the north-south, so this is also talking about the north-south light is green, which means is 0. Okay, the north side is green when either A or B is occupied while C and D are both vacant. Okay, think about that and see how many options you can get. Once you are able to reach the number of the possibilities, you can put it there and then we go from there. Okay, some of you are putting it. Jesus, okay, correct. The number is correct. Josh, the number is correct. Tony, rethink it. You're overthinking maybe. You have some extra. Rosa, you're also, again, overthinking. So that's too much to be the possibilities. Danny, no. It's less than that. Jacob, yes, correct. Anahi, correct. I just hope I don't miss anyone. Sarah, you rethink it. You have something extra there. Okay, Nicholas, I think you have something extra. Rosa also, though, it's less than that. Marcus, it's less than that. Diego, that's correct. Tony, that's the number is correct. Danny, the number is correct. Rosa, yes, the number is correct now. Marcus, number is correct. Mark, okay, you're going to notice that one of your entries here is repeated in the previous one, so it's not those. You take one of them out. Okay. Eduardo, no, you overthinking. It's less than that. Sarah, that's correct. Marcus, yeah, Marcus is correct. Okay, good. I think, guys, you put things. Yes, Nicholas. Yeah, that's correct now. Because the one of them is from the number 3. Marcus, yes, good. Yeah, that's right. Brian, correct. Eduardo, correct. So I would like, okay, I'm gonna stop here, and I would like Danny to unmute and tell me how did you think about how did we get those? Okay, just put the A, B, C, D.
So C and D have to both be vacant. So the only possible values for that would be 1, 1.
Vacant.
Oh, my bad. 0, 0.
Okay, so that's the only one here is going to be 0, 0.
And then from there, you have either A or B is occupied. So it's all the possible values except for 0, 0, but one of them's repeated. Which.
Yeah. Okay, so it says either A or B is occupied, which means that one of them has to be occupied while the other is not. So we're going to eliminate the option that both of them are occupied and that both of them are vacant.
Okay.
Right? So if here, these are the 4 possibilities. This is the possibilities that both occupied. This is the possibility 0, 0, possibility of both vacant. But now I'm saying that either A or B is occupied. So I'm going to take either A is occupied or B is occupied. So it cannot both be vacant. It cannot both be occupied. So it's only 2 options here. So these 2 options are going to go with the 0, 0. One of them is 0, 1. One of them is 1, 0. And that is my other option. The one that some of you were doing is that when both of them are occupied, which is 1, 1, it's already exists here. So even if you put that, you're just, when you try to fill in your truth table, you're just going to find that you duplicated it. Is that clear?
So we'll think as either as just one, even though like technically it could be like when both are there, but since it doesn't say both, we won't include it.
It should, yes, that's what I'm saying, that either A or B is occupied. I didn't say both of them can be occupied, or one of them. The wording is very important. You see the north-south, the one before it, we said both are occupied. It limits your chances a little bit. When I say either one of them is occupied, okay, it's not at least one of them is occupied. If it says at least one of them is occupied, so I can put the option that 2 of them are occupied, but it's saying that either one of them has to be occupied. So it's only the 0, 1 and the 1, 0. And of course, C and D are not both occupied. It's just telling you that they're not both, they are both 0 and 0. Sorry, while C and D are both vacant, so both of them are 0 and 0. Okay, so this is, it gives you, this is very straightforward and it gives you the right answer right away. Any questions so far? Okay, so now let's move on to number 5. Any questions? Someone was unmuting?
No, ma'am. Thank you.
Okay, so now let's move on to number 5. Number 5 says the east-west light will be green. Okay, now it's talking again about the east-west will be green when no vehicles are present in any lane. This should be easy. Okay, many of you, so far everybody wrote it. Tony, just rethink it. There is possibilities. This cannot be 0. Oh, okay, you put the possibility. Okay. And okay. No, Jacob, it's not right. Eduardo, Anahi, Jacob Roybal is right. Sarah, Tony, Rosa, Marcus. Those are right. Nicholas also is right. Jacob Kessel, you did something extra. Diego, correct. Marcus, correct. Brian, correct. Danny, okay, good. So probably most of you got it. Okay, so Tony, unmute yourself and tell me what is that possibility? How many and what is it?
I just got the possibility, 0 possibility when there's 0, 0, 0 in AB and 0, 0 in CD.
Wonderful. When I say that no vehicles are present, it means that there's nothing in AB, there's nothing in CD, and that's it. That's the only option that I have. So here I come up with 1 entry, here with 2. So this is 3 plus 3, that's 6. And I have here plus 6 plus 4. Now I get all my 16 possibilities that I can use to fill in my truth table. But I still have some, pieces of information that are almost very critical, and it can hold like 90% of your design. It didn't come yet, okay? Now I want you to read, and that's what it's gonna come in the next paragraph right now. Like, this is the most important one. I want you to read it carefully, and then you're gonna write down in the chat box, what does that mean? And if you can get this one right, there's consequences of that in your design that's going to make it so simple. And if you don't get it right, it's just going to make it so complicated. So I call it the golden rule of this whole thing here. So read it carefully. Once you're ready, put it in the chat box. What does that mean? It means an equation. Okay,
Wait.
I don't want you to put it in a wording. I want you to put it in a Boolean expression.
Oh, okay. I was gonna ask
So
that.
Rosa and Jesus, try to put it in a Boolean expression. What does that mean? Like, what does that mean regarding the east-west and the north-south? Try to formulate it in an equation. Okay, Jesus, you got it right. Good. Eduardo, you might want to say it, but you didn't really put the formula correctly. Nicholas, also, I feel like you understand the concept, but you are not able to get the correct formula. The formula is going to be between the east-west and the north-south, not between the inputs. Marcus, the same thing. Because it's talking now, it didn't talk about the vehicles. It's talking about the green light and the red light. When one is green, the other is red. So it's talking about the outputs, not about the inputs. So don't think about the inputs, think about the outputs. Okay, Rosa, that's right. What does that mean? Now put it in a formula. Nicholas, good, wonderful. So once we get the answer, we still, there's more. One critical thing is how I'm going to use that to my advantage. But right now, I just want to know what is the relation between the east-west and the north-south using that paragraph wording. Anahi, wonderful, you got it right. Rosa, you're still getting close. Still that's no, it's the relation is not an OR gate. Josh, okay, just rethink it. Just try to think, keep thinking until we say the answer. Rosa, no. I think that you're getting close, but you are like maybe thinking in a higher level. That's why you're trying to get things more complicated. No. It's more simple than that. I need Marcus, rethink what you wrote, Eduardo. And I need the rest. So Brian, Danny, Diego, Jacob, Joshua, Mario, Mark, Patrick, Sarah, and Tony. No, Josh. I think you're starting to, okay, you're starting to think in the right direction, but it's not yet there. You're not yet there. Jacob Roybal. It's not correct, but I think that you're trying to think in the right direction, but you just were not able to get it right. Sarah, yes, that's correct. So can you write it in an expression? Josh, again, you might be overthinking it. I need the rest. Think and just put whatever you have. You're not going to be accused for anything right or wrong. It's just showing me how you think about it. Okay, Danny, that's correct. If this is 0, this is 1. If this is 1, this is 0. What does that mean? Now you put it in an equation. What does that mean? Sarah, no, that's not it. You might need to rethink it. So Danny, you're very close. You almost got the answer, but you just need to put it in an equation. No, Marcus, I don't want zeros and ones. I want a general equation, like a general relation between the east-west and the north-south. Eduardo, I feel like you understand what's going on, but you're not able to put it in the right formula. The formula is not right. So just try to rethink it again. Did Brian put an answer here? Brian, what's your thought about it? Mark, Mario? Okay, Sarah, can you unmute and can you unmute and tell me what the one that you wrote down here?
The equation that I wrote down?
Not the equation, the wording that you were, the first answer you did.
Oh, okay. So I know when you have a not that it's gonna be complemented. So what I thought would be the EW will be complemented together and the NS will be complemented. So
the east-west is one thing. It's just called EW. So that is one entry. And the north-south is another entry. So these are two outputs. The east is not alone and the west is alone. These are one thing. So east-west, this is an output called EW, another output called NS. You're saying it right. There is a complement there. So what's the complement between? Between what and what?
And I think, would it be 1 0 or 0 1?
Yes, okay, but okay, let me go here and let me show you guys something that might make it easier for you. So for the east-west, okay, for the east-west, you have a traffic light here and a traffic light here. Both of them are working together. So these two are reds and these two are green. So you think of it as one output. That is only one output here. That's called east-west. And then you have another traffic light here, and you have a traffic light here for the north-south, and those two also are working together. So what we're saying in the entry, in the paragraph, we said that if the north-south is green, okay, so if these two are green, then at that point, the east-west is gonna be red. And of course, if the north-south is red, the east-west is gonna be green, which means that these two outputs are complementing each other or the opposite of each other. In other words, it means that in my truth table, if my east-west is equal to 1, in the truth table, I'm going to find that my north-south is equal to 0. Okay, and if my east-west is equal to 0, my north-south is equal to 1. What does that mean again? It means that my east-west is just the complement of north-south. Or in other words, the north-south is just the complement of east-west. Okay, so that's what it means. Because when you're trying to fill in your table, now let me tell you this, when you're trying to fill in your table, we came up with 16 possibilities, but some of them are for the output EW, and some of them are for the output north-south. Okay, now if I don't have a relation between the east-west and the north-south, I won't be able to fill in my whole table because I need to fill in those 16 entries for 2 outputs. But I only got from the first output, east-west, I got 4 entries here and I got 6 here. And for the east-west itself, I got 10 entries and this is 1. So I got 11 entries for the east-west. And the rest of the 5, I don't know what the output is going to look like. And for the north-south, I got 3 and 2. I got only 5 entries. And for the other 11 entries, I don't know what's going to look like. But when I combine them together with the relationship that the east-west is the complement of north-south, so whenever I see in my truth table that the north-south is equal to 0, I know that at that particular point, my east-west is equal to 1. And if I have an east-west is equal to 0, I know that my north-south is going to equal to 1. So the same thing here. If this is north-south equal to 0, it means that my east-west is equal to 1. The same thing here. My north-south will equal to 1, and here my north-south will equal to 1. Okay, now let's see how that's going to affect our truth table, and then how that's going to affect our design. Okay, I didn't tell you yet the trick that's going to make it easy for you to design. So right now, I think you have all the possible entries. What I want you to do right now is to write down this truth table. And you're going to start to fill in the east-west and the north-south with the possibilities that you have. Now, the answer that you're going to put down, and this answer is going to be graded based on your understanding. It doesn't have to be completely right, but at least it shows that you're paying attention here. I'm going to take the names here. What you're gonna do is you're gonna tell me the east-west is equal to summation, and you put all the entries where it's equal to 1. And you're gonna do the same thing for the north-south. So this is midterm 0, this is midterm 1, these are the locations, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which means that if I have a 1 here, for example, you're going to write it at location 13 for the north, south, and so on. So let me just erase it so you don't think that that's a correct answer. Okay, so I'm going to give you like 3 or 4 minutes. Look at all the entries that you have so far from the previous ones, previous slides. Try to plug in the things you have, fill in the table, and come up with your east, west, and north, south midterms. What are the midterms? And I can get you, this is the first one. Of course, here they're not in order, so you're going to have to find them in the truth table.
Just to clarify,
Mhm.
the output is green when, or the output, it's green when the output is 1, right? Correct?
No, green means the output is 0.
Okay.
What did you want us to put in the chat box again?
What you're going to put in the chat box is after you finish all of the truth table, like you put the 1s, you put the 0s, you're going to tell me the locations of the 1s in your truth table for the east, west, and for the north, south. Because you're going to fill your table with 0s and 1s. Once you finish your table, like for example, you have here some 1s and oh, this got so big. Okay, so you're going to say, for example, the locations here, it's at 3, 4, 6. I'm just putting names. That's not correct, but I'm just putting things. So you're going to say at 3, 4, 6, and 8, for example. These are the ones that are north, south. And for the east, west, maybe these or whatever. So you're just going to put the numbers of where the midterms are equal to 1. If you got it right, then the whole truth table should be correct. So that can tell me how I know that you did the right answer.
So you just want the midterms, not like the sum of products equation?
No. Just put the numbers. The locations of where you have the 1s. It doesn't want to erase it. Okay. Okay, it doesn't want to erase what I put there. Just want to just take this all out. So actually what you're doing now, I'm working with you out your pre-lab. So once you get that right, you should not have a problem doing your pre-lab. Okay, so Brian. Yeah, I think you have one missing, Brian. So the east-west is correct, these numbers, but you have one missing. Danny, okay. Wonderful. The east-west is correct. Let's look at the north-south. Wonderful. Okay, so Danny, you got them. Let me just turn in here. Okay, please put the east, west, and north, south together. Don't put one. Put both of them together, please. So that's easy for me to grade and put that you got the two of them. So Josh.
So I have a question.
Okay, let me just me 1 second. Okay, Josh Perry. Yes, you got the north south correct. Please put the east west right away so I can put your grade. Yes, go ahead and ask.
Okay, I was gonna ask, does the table start from midterm 1 or does it start from midterm 0? Like down, up,
No.
from down.
I didn't get your credit. Well, when we were talking here, we said that the north south here is equal to 0. That means the greens, and then the rest is going to be filled with ones.
Okay, now I was thinking about the midterms, like, you know, like in order, because I got 1 through 15 through 16, like in terms of midterms.
Yes, you're going to write it with the midterms that's equal to 1, 0, 1, 2. You go all the way to 15.
Okay, thank you. I was double checking.
Okay, let me see here. Okay, Josh Perry. Yes. Okay, I got your other one. Let me just check this one. Hold on a second. Where's my paper? Okay. Okay. So Josh Perry, you got it right. Thank you. Let's go back here. Okay, Anahi, 1, 2, 3, 4, 5. Okay, good. 3, 6. Wonderful. Okay, Anahi, you got it correct. Anahi. Now let's go to Jacob Roybal. Good. 1, 2. Then wonderful. Okay, that's correct. Let's see who is okay. Nicholas. Oh my. Nicholas, no. It seems that you're mixing the zeros and the ones. You are mixing the zeros, and please pay attention. Go back to your truth table and check on things. You're going to fill it first with the zeros and ones, and then you're going to try to check your midterms. You don't just take where with the green lights. Okay, the green lights are zeros. Sarah, east, west. Okay, north, south. And okay, good, Sarah. You got it correct. Rosa, let's see. Wait. Okay. Rosa, you have the midterms correct, but the names are not. The east-west is the other one, is the second one, and the north-south is the first one. So probably what you did is that you were counting the zeros, or maybe in the truth table, you put the zeros instead of the ones. I just want to make sure that you because what you have here is the east-west is your north-south. What you have in the north-south is your east-west. Both of them are correct, but they're not to the right corresponding output. So I want to make sure that your truth table is correct, or either your truth table is flipped or you picked the zeros instead of the ones. Brian, correct, good. Now let's look at Eduardo. Eduardo, what are you putting? No, Eduardo, it's just going to be numbers. Like you're going to say midterm 1, 2, 3, 5, 7, 9. That's what I want. Marcus. No. Oh, okay. I will hold on. So Eduardo, it's not zeros and ones. You're just giving me a number. You're just saying that it's a 0 at the location 0, 1, and 5, and 7, and location 10. That's what I'm looking for. Rosa, 4, okay. Okay, Rosa, maybe you put it by mistake. In the north-south, 1, 2, 3, go to the 5th entry. You're going to notice that you have it also in the east-west. It cannot happen. So probably this number needs to be changed. But other than that is correct. Marcus, no. And they can't be the same midterms. If the east-west has midterms numbers, the north-south is just going to be the opposite. It cannot both be the same thing. Jacob Castle, 4, okay. Correct, wonderful. Okay, I want your entries quickly because I'm gonna stop shortly so I can continue. Jesus, okay, what you have here is not the north-south. It's correct for the east-west, but not for the north-south. So probably you're doing the same mistake. You're either flipping your zeros and ones, or you're taking the midterms as your zeros, not as your ones. Diego, correct. Tony, okay, Tony, you have some of them are right, some of them are not. You have some mix and match there. It's not correct. Jesus, yes, correct. Now you got them right. You got the numbers right, but not the corresponding outputs. So the north-south should be the second entry. The east-west should be your first entry. So I'm not sure what you did wrong.
Okay, I just took them in terms of once, but I can flip it.
Okay. So probably that's what you did.
I'm
East
a
west
little
is 0. Eduardo, no.
confused. So are we like trying to find the midterms where it's a 0 or a 1 because 0 is green?
One midterm.
Okay.
You're always looking for the ones.
All right.
Okay, Joshua. 8. Joshua, your north-south has one wrong one. One entry, one of the midterms is not correct. The last one is not correct. And that is also for the east-west. You're doing the same flipping problem. And the second one, that is supposed to be the north-south. Also, you have something missing there. Okay, let me go here. Okay, I'm gonna stop here. I can't take any more. Okay. Okay, Rosa, yes, you have that right. Okay, and Eduardo, okay, you got that one right for the east-west. Okay, so I'll just give you a grade for that one. Eduardo 1. Okay, so just for the sake of time now, when we're trying to fill in the truth table, you're looking at what we have here. So when I say the east-west is equal to 0, it's going to equal to 0. The first easiest one is when all of them are zeros. Okay, so when all of them are zeros, this is going to be 0. And because I know that the east-west is the opposite of the north-south, so this is going to be a 1. Okay, so whenever I have the east-west is 0, I know that the other output is going to be 1. Now the other outputs here, let's take it here for when the CD is equal to 1, 1. I want to put all the possibilities for A and B. So when CD is equal to 1, 1, 1, 1, 1, 1, 1, 1, okay, that's when my east-west is going to equal to 0. And of course, if this is 0, this is 1. You see, so you're filling in the other one automatically if you know something in that one. Now let's move on to this one. It says that when your CD are both zeros, and then you have 0, 1, 1, 0. So let's see, when CD is both zeros here, they're going to be both zeros here, here, and here, but I only need the ones that has 1, 0 and 0, 1. Where's 0, 1? Yeah, this one here. And this is what? This is going to be for the north-south. Oh, did I? Okay, so we filled this one. Okay, we filled this one. We're done with this one. And I jumped into that one, sorry. I jumped into number 4. So when CD both 0, 0, this is 0, 1, and 1, 0. This is the north-south is equal to 0. So for these two options, the north-south is going to equal to 0, and therefore your east-west is going to equal to 1 because they're opposite of each other. So you're just going to take every table and do it like that. So let me just put the final answer here for you. 1, and then you have 3 zeros, and then 1, 1, 1. And of course, once you have a 0 here, it's going to be 1 there. Once you have a 0 here, it's going to be 1 there. Okay, once you have a 1, it's going to be 0 the other way around. So your east-west, okay, your midterms are going to be, okay, this location. So you have 5 locations. This is 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14. Oh, did I miss up? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so my east-west is going to be at 4, midterm 4, 8, and then 12, 13, and 14. Now the north-south, okay, it will be all you need to count all the other ones. So that's one way, or anything that is not in the east-west is going to exist in the north-south because it's the complement of it. So I will have here, I don't have the 0, 1, 2, 3, I have 4, I don't have 5, 6, 7, I have 8 there, I don't have 9, 10, 11, I have the 12, 13, 14, I don't have the 15 there, okay? So that's going to be the north-south. Now the next step for you, and I'm not going to do that with you, that's your part, is that you need to find the Boolean expression for the east-west and for the north-south, okay? I would suggest that you use K-map, okay, to find it. Now, I want you, before we leave, because if you leave like that, I know what you're going to do. You're just going to find the K-map for the east-west, you're going to find the K-map for the north-south, and the north-south is going to look a little bit ugly, and you're going to end up having a lot of headache there. I want someone to tell me, how can I make use of this equation? In writing your implementation, like writing the Boolean expression and implementing it on Tinkercad. And that's going to be worth of a lot of credit if you're able to get that answer.
Couldn't we just, like whatever equation we get for EW, just complement it to get the north-south? And then for the circuit, we could just like put it into the inverter, like the output for EW?
Who's talking?
Anai?
Anai. Okay, wonderful. Excellent. So let me just put that here for you. Okay, for extra credit. Wonderful. So as she said right now, that's the golden rule. And instead of taking these two, finding the Boolean expression for both of them, I can find the Boolean expression for one of them, and it's your choice. You pick up the east-west or the north-south. I'm not gonna, force you to, it's up to you. You say, okay, I wanna find the east-west, and then I'm just gonna complement it, or yeah, take the complement of it and get the north-south. Or no, I wanna calculate the north-south and find what's the Boolean function for it and just complement it and get my east-west. That's for the writing down your sum of products Boolean expression. Okay, that's number one. Now in the implementation, which is the most crucial one, is that instead of me as an engineer, if I just don't rethink it and I just, work like a machine and say, okay, I need to implement the east-west. This is how many AND gates, OR gates, NOT gates. And then I create another circuit, a whole circuit that is expressing my north-south. Now, instead of doing that, you're gonna think in a smarter way. And that's what Anna did right now, is that she said, I'm just gonna build one circuit. Okay, and the output for that circuit, whatever the circuit you chose to build, maybe you chose to build the east-west, and then you're taking this output here to the green and red LEDs for your east-west. Okay, so this is your first output. Well, what I can do is that for my north-south, I'm just gonna pass it through an inverter and put it here. So when this is red, this is gonna be green, and when this is green, this is gonna be red. Then I don't have to build the other circuit. Okay, or maybe I'm just gonna build the north-south because maybe for me it looks more easier, whatever. That's something you're gonna figure out which circuit you want to build, and then I'm just gonna do the same thing. Okay, so instead of building, it looks like it's a big circuit and you have two parts of it to build, but if you understand this golden rule here, you understand that you only need to build one circuit and take the output inverted to get your other circuit. Only an inverter. It's just going to pull down to an inverter, this complement here, instead of building the whole circuit again. Okay, so I don't have to build east, west, and north, south. I'm going to build one, invert it to get the other. Which one I'm going to build, it's totally up to you. So you can start with the east, west, you can start with the north, south. If I am an engineer, what I will do is I might spend some time finding the Boolean expression for the east, west, and north, south, and look at both of them and see which one has less gates. That's what I will do. And think of, okay, maybe the east, west has only two ANDs, one OR, blah, 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 or the north, south is the one that has the least number of gates. Then I'm going to build the one with the least number of gates. I don't want to, cost more, have more speed, take more time. You just need to be smart about your design. Okay, and also when you're trying to do the design, like for example, this is not an answer, I'm just giving you something random. Like if I say A, B, C complement plus A complement, B, C, whatever the numbers are going to come up with, you don't have to take it as it is. You can do combination, which means that, okay, if I take the B here, if I take the B here, maybe I have AC complement and A complement C. Okay, then that looks like an XOR. So you can take parentheses, take common factors. After you get the simplified form, you can start to rewrite it so that you end up with a less number of gates. So that's the engineering part, that you're going to play with it. And even if you do this design, it's still going to be correct, but you're doing it like the textbook says, and you don't use creativity in trying to reduce the number. Okay, if I do this, maybe I would reduce the number of gates I'm using, and so on. Okay, so there's going to be some kind of creativity that's left to you, but you need to get the expressions correct for the east, west, and for the north, south. So that is something that you're going to put in your pre-lab. And I will be, me and the TA, we will be checking on that on Thursday morning with you. Whenever we go to the groups, we have to check on that. So I most probably, I will reveal the correct answer for the east, west, and north, south on Thursday after you submit your pre-labs. And it's still up to you to choose the east, west, or the north, south to build it. Okay, so you still have this kind of freedom to pick one of them to do, and to put the different combination you want with any of them. Okay, any questions so far?
No,
any
ma'am.
questions?
Thank you.
What do we submit as our pre-lab?
The pre-lab is going to be Thursday morning before the lab. I walked you through most of it, so that's why I didn't delay it, because now the most important part, or the hardest part, is how to create your truth table. So we created it together. You have your midterms, you just need to plug it in a K-map and get the expression, and then come up with your schematic diagram that you want to design on your Tinkercad. Okay, so it's still gonna be Thursday morning before lab time. You have to submit your pre-lab. Any questions?
No, I meant what?
Like, what do we submit physically to the pre-lab? Like,
Yeah,
do we need a
if you
diagram? Do
look
we
at
need-
the lab, you're gonna submit the truth table, and you're gonna submit the expression for the east-west, for the north-south, the schematic diagram, like something like this, what it's gonna look like, you know, if it looks something like that, whatever your shape is gonna look like, and your template, your layout on the Tinkercad, like this is my AND gate, my IC chip for the AND, this is for the OR, this is for example for the NOT, and I'm going to be connecting whatever, these are the two inputs, this output is going here, this output is going there, and this is my LED. So you're going to have that layout, and you're going to have that schematic diagram, you're going to have the expression for the east-west, you're going to have the expression for the north-south, you're going to have your truth table there. If you look at the lab that I put there as a document, as a Word document, and as a PDF, you're gonna find the steps that you need to fill in. But you don't have to do it. And if you don't want to print out and fill it in, you can just put it on another piece of paper. But it has to be legible writing.
Do we have to do both schematic diagrams, even if we're just planning on inverting one to show the other?
No, you just need to do one of them.
Okay.
Yeah, because you're gonna just put an inverter and say that that's your second output. So let's say this is your east-west output. You're just gonna put an inverter and say that's your north-south. And that's
Okay,
the same thing for the implementation here, because that's what you're gonna do.
Okay, thank you.
Any other questions? Okay, so see you on Thursday.
You too, take care.
Oh wait, I have a question. It says this is a group lab. Are we gonna be working in groups?
Yes, you're gonna be working in groups just like the regular lab and submitting the report together, but the pre-lab and your Tinkercad, everyone is on its own. Okay?
Okay.
Okay.